Hello, my name is Wayne Busek and I am an IT specialist with IBM. Today we will be discussing some of the options available for managing service provided by z/OS Connect. z/OS Connect is an industry-leading mechanism for exposing legacy assets to the cloud and the internet. Truly the gateway to the enterprise, z/OS Connect implements RESTful APIs to and from your IBM Z mainframe. These RESTful APIs enable access to back-end programs, whether they be CICS, IMS, MQ, or other, in a manner which is controllable and secure. Along with the business benefits that z/OS Connect brings comes the technical challenge of delivering good service to users across differing access channels with new usage patterns and increased transaction volumes on the system of record. Here we depict the traditional war room conversation, with all of the parties associated in enterprise application troubleshooting weighing in. This notion is not new, but consider the components of the enterprise now include z/OS Connect and increase the ways which applications can be accessed. As the links in the chain increase, so does the need for sophisticated tooling to assist in problem analysis. To accommodate this, IBM has partnered with Appdynamics. Appdynamics is a leader in the distributed systems management space, providing diagnostic insight to the performance of applications on distributed systems. However, Appdynamics offers zero insight to application activity on the mainframe. IBM Z APM Connect functions like a plugin to Appdynamics, collecting information regarding application performance on z/OS and making that available to Appdynamics GUI. This single source of truth minimizes time spent in the war room and expedites problem resolution. An application topology view displaying the health of all components is the key to problem resolution. In this view, we see that an enterprise application initiated on a distributed web server connects to z/OS Connect to access back-end applications. In this case, a request is passed from z/OS Connect to a downstream CICS region. We see the response time hops as well as a count of executions of each piece of the workload. On the right-hand side, we see a fan-out of delays experienced for resource requests by the application. z/APM Connect provides a CICS-centric view of the health of an application, dealing with the time spent in each of the categories listed. Here we should note that all data collected by z/APM Connect is available for use like any other metrics found in the Appdynamics GUI. z/APM Connect supports a finite list of application flows. Here we see, starting at the left, execution origination points for supported workloads. Appdynamics is installed on those endpoints and is configured to monitor that application. z/APM Connect code, running as exits or interceptors on Z, monitors for the presence of an Appdynamics singularity header as requests are processed. When the header is found, z/APM Connect initiates data collection on the mainframe components of the application. The Z-based data is compiled on the host, then forwarded to the z/APM Connect distributed gateway, which makes the data presentable to the Appdynamics controller. Up to this point, we have been focused on response time information, identifying slowdowns in workloads, and specifically isolating the failing component. Now that we have found the weakest link in the chain, it is time for more detailed diagnostic analysis. There are two approaches here, and the first we will consider is performance monitoring, in this case using OMEGAMON for JVM. OMEGAMON for JVM is a real-time monitor which will dynamically find all JVMs running in your environment. JVMs are embedded seemingly everywhere these days, as many subsystems now leverage Java. Detailed statistics on memory heap, CPU utilization, thread status, and more at the subsystem level are provided. However, the item which sets OMEGAMON for JVM apart from other monitors is the z/OS Connect request monitoring. OMEGAMON for JVM collects request information for all transactions processed by z/OS Connect. The primary data collectors are z/OS Connect interceptor code along with the Java Health Center, and using these two collectors, OMEGAMON makes all of the comprehensive information shown on this screen available for display. The data is available in real time and can also be retrieved for display in various historical time frames. This request summary panel shows aggregate activity for all requests over the selected period. All of these columns are sortable and filterable, and each row can be selected for a focused display on that item. Here we can drill down to detail on a specific API. The request analysis screen shows all executions of the addresses API. The left-hand column shows us the event time for each individual execution. Across the columns, we see the total request time, z/OS Connect time, system of record time, along with the service name and the back-end system of record. Notice that there is a yellow arrow in the middle of the screen indicating that data which can be seen by scrolling to the right has exceeded a display threshold. There are 10 other columns of data available for display. Selecting any row of data will take us to the lowest level of information available here. The detail level statistics display provides full detailed information on an individual execution of a request. Here we see the time the request executed, the type of request, the API name, associated URI, and method invoked. These identifiers are followed by an execution time breakdown including total time, time spent in z/OS Connect, and time spent in the system of record. This is the most granular data made available by z/OS Connect. The analytics approach is another means of detailed performance analysis. There has always been a massive amount of operations data produced by Z systems. It is only recently that we have introduced mechanisms to collect and distribute this data in near real time. Common Data Provider is the central point of an analytics approach. Data streams like SMF data, syslog, subsystem and application logs are collected by data gatherers. This data is then streamed to an analytics engine for correlation and visualization. Operational data sources include z/OS Connect SMF records, IMS Connect extensions records, NetView Netlog, and IBM Workload Scheduler logs. Additionally, CDP is the preferred mechanism for streaming the performance and capacity planning information produced by IBM Z Performance Capacity Analytics. Common Data Provider supports streaming data to Splunk, Elasticsearch, IBM Log Analysis, and other analytics tools via Logstash output plugins. Finally, Common Data Provider can store analytics data in DB2 on z/OS for use with Watson Machine Learning on z/OS and in IDAA when dealing with IZPCA key performance metrics. IBM Z Operations Analytics features dashboards designed to assist in operational monitoring of z/OS systems and subsystems. Here we see the z/OS Connect API dashboard. Key metrics on APIs are displayed via charts and in tabular format. On the left, we see the top 5 APIs by transaction rate across the entire sysplex. Below that, top 5 APIs in terms of elapsed time are displayed. In both cases, the detailed records associated with the reports are listed on the right side of the page. Drill down to URI or service associated with an API is available from both charts and tabular views. By scrolling down on the dashboard, further reports are exposed. In this case, reports based on data rate, error counts, error codes are also found further down the page. Drill down from the API dashboard yields the service dashboard. Following the same format, the top 5 services by transaction rate and elapsed time are displayed. In this case, the top 5 services relate to the Stock Manager API executed anywhere in the Sysplex, Plex 1. The same metrics found on the API dashboard, transaction rate, elapsed time, data rate, and error rate and count, are the basis of the reports displayed. These reports and others are available in seconds via data streaming. Key aspects of data streaming include having a wide range of supported SMF types. Common Data Provider has the largest number of supported SMF record types of any streaming product available today. As I mentioned earlier, data streams extend beyond SMF to capture system and application logs vital for correlation and visualization of enterprise applications. The cost of data collection is mitigated using advanced filtering techniques, which are implemented on the host. Reducing data collected and ultimately the volume of data ingested can reduce the total cost of ownership of your analytics platform. On the host side, Common Data Provider's components are zip-enabled, thereby not using cycles, which are counted as the basis for software charges. Data streaming is one component of the Z Operations Insight Suite. The Insight Suite is a holistic analytics solution comprised of near real-time and historical analytics components. The three blue blocks on the top row represent capabilities found in IBM Z Operations Analytics. We have already looked at z/OS Connect dashboards, which can be used for system monitoring. In addition to that, IZOA's anomaly detection delivers a predictive capability highlighting potential problems prior to service interruptions. Two types of anomaly detection are provided: metric-based machine learning using SMF data as the source of analysis, and message-based machine learning using IBM Z-Aware to ingest and analyze Opera log messages. The bottom three blue blocks represent capabilities found in IBM Z Performance Capacity Analytics. IZPCA is a traditional performance and capacity reporter harvesting SMF records for use in numerous system and application reports. IBM Z Performance Capacity Analytics is a complete capacity planning solution. System metrics are collected and made available for reporting in near real time. IZPCA's timely delivery of data and reports gives performance analysts access to key reports while performance problems are still occurring. Using reports that were previously unavailable until the following day contributes to reduced downtime and improved service. As with IZOA, data curation is a centerpiece of the solution. Key performance metrics defined during the curation process reduce the total amount of data stored while enriching the data itself. KPM fields are added by performing calculations on data contained within the records. Capacity forecasts and what-if capabilities project system utilization when hardware upgrades are introduced. Specifically related to our current topic of z/OS Connect management, IZPCA has a full complement of reports related to z/OS Connect. SMF Type 123 Subtype 1 records are used as the source of information for these reports. Full historical analysis of z/OS Connect processing at the system, server, and API level are available. In this brief video, we have discussed an approach to managing z/OS Connect. z/OS Connect offers many business benefits, but along with those benefits come new technical considerations. A holistic methodology combined with sophisticated tooling is required to continue delivering high-quality service. IBM's total solution combines a response time perspective with detailed real-time monitoring and operations analytics. Once slow or failing application components have been identified, detailed monitoring and operations analytics can be applied to the failing components. Historical analysis is available to determine trends, with forecasting capabilities to anticipate future resource requirements. There is a great deal of information available on the IBM website regarding all of the content we have discussed today. Product-specific introductions, detailed descriptions, announcement letters, and case stories are found at the links shown on this slide. For further information, contact your IBM representative.